Um, so I'm just having a little trouble finding it. If you could give me just another minute.
Okay.
Okay, so I'm gonna go ahead and upload this now to Whiteboard 1,
Okay.
and we'll go from there. So hopefully you can see that on your end by now.
I can.
Okay. So I'm not too sure. Of course, I'll give you some time to read the question, but the issue I think is I don't think it's the concept or the algebra. I think it may be an issue with the way that I'm perceiving this question to be. So I guess I'll give you a
Okay.
second or two to read this, and then we'll work from there.
So I see they're 500 miles apart. Car A's to the west. Car B. Car A to the west of car B. And initially they're 500 miles. Car A is heading in that direction at 35 miles per hour. And then car B starts driving south. 50. After 3 hours of driving, at what rate is the distance between the two cars changing? Is it increasing or decreasing? Okay, so I see everything there. So what questions do you have at this point?
So this was a sort of a similar diagram that I was able to draw out, and the diagram that they're showing in the solution is it's somewhat similar but different enough to sort of ruin I think the calculation. So let me go ahead and also attach the diagram that I was given, and maybe they're similar, maybe they're not. I'm just not too sure. So on whiteboard 2 here, I'll put, so this is, so as you can see here on whiteboard 2, this is what they had as a diagram. Does this match our line of thought, or is it different?
It does. The only thing we haven't done yet is account for the 3-hour travel of time. So if we looked at car A, it was traveling east at 35 miles per hour. So that means it would travel 105 miles in that time. So that means, how far away was it from it initially? So if we looked at the X, we can find that distance. So the distance that was driven by car A was 105 here. So then that would make this 395 from the initial point that we started with as far as car B. And then car B is going 150 miles per hour. So if they're traveling for 3 hours, then they would have traveled 150 miles.
So this conclusion that you've came to, could we have came to the same conclusion in our initial stages of drawing our diagram?
Yeah, that would have been the next step. Yeah, that was just to kind of start it off. But then, yeah, if we would account for the time to see, okay, where are they at from where they initially started? So then we can make the triangle that they have here in the figure.
Okay. Because it just never struck me really to make that adjustment for car A, and I don't think it does even now, to say that my original diagram will, I think the diagram that you had is the diagram that I have, and I don't think I would sort of propel car A in car B's direction after 3 hours, because I think 3 hours is the time frame where I'm trying to find the rate of change, right? So I don't.
That's right.
It just doesn't strike me as a parent to.
Yeah, I mean, I guess eventually when you're starting to work out the problem, when you take the derivative of this triangle, which is going to be a right triangle, so you know you're going to use Pythagorean's theorem. Well, within that Pythagorean's theorem, we should have an x and y value that we're going to need to plug in for. So we need to know what those values are. So at that point, that's where we need to make that assumption that, okay, well, what is the distance that x represents? What is the distance that y represents? That x is going to be, well, how far is car A from the initial point of where car B was? And then the y in the figure is going to be, well, how far did car B travel south during that 3 hour time?
Okay, so you're saying that if I'm correct in interpreting your line of thought here, you're saying that we would have to use the Pythagorean theorem because we are dealing with a right angle triangle, and since we're dealing with a right angle triangle, we would need the length of some sides. But I would argue that we already have a length of 500 miles, right? So making a new adjustment onto the length that we already have isn't that apparent.
But they want to know what is the rate after 3 hours. What I initially have drawn, and you said, you had something similar to it, that's my time 0. That means the cars haven't moved anything. So I need to go ahead and adjust to the time frame. Doesn't matter if it's 1 hour, 2 hours, 3 hours, whatever it is. I need to adjust to the time that we've already been given at this point.
But those adjustments are made after taking the derivative of the Pythagorean theorem, right?
Yeah, we could do that. Yeah.
So if we don't make that adjustment at the diagramming stage, would we be fine?
That's fine, because taking the derivative of the x squared plus y squared equals z squared with respect to time is still going to give you the same function. What's going to affect your answer is that once you do take that derivative and then you start plugging in values, that's where you need to make sure you put the right values in.
Okay, so let's go ahead and try proceeding without making the car A's adjustment at time 0. And I guess we'll see where that gets us. So it seems like we're definitely going to be using, so I guess if we were to plot this a little formally here, sure.
So yeah, that's since we have that right triangle, that's the formula that we can go ahead and use at this point.
Okay, and so do you want me to take the derivative of this, or are you're gonna?
Yes, that's
okay.
Right.
Sure. So I guess we'll have, so taking the derivative of, I just want to figure out if I'm dealing with any constants in case they go to 0. So I think the only constant that I would have is I don't think I do have a constant here. I don't think there are any constants. They're all changing.
Yeah, not in this case. Yeah, I mean, there's some that when you have a related rates, like maybe you have a ladder.
Yeah.
And the length of the ladder doesn't move, so then that would be a constant. Yeah, exactly.
Absolutely. So I think that's, and I think the question, so I think the question gives us, let's see here. So it says that two cars start at 500 miles apart, and they're driving east. Car A is driving east, or car A is driving west, and car B starts driving east at 35 miles per hour at the same time. Car A is to the west of car B and starts driving to the east. Okay, so car A is we're given the derivative of, we're given the rate of change of car A, it seems. So if A was, if this side here, if the height of the triangle is regarded as car A's side, are we regarding that as X or Y?
X.
X? Okay. So what we're given is dx over dt at being 35 miles per hour. And I also believe that dy over dt, and dy over dt is also given at 500. So dy over dt is also given at 500 miles per hour.
It should be 50.
Oh, right, 500. Of course. Sorry, my bad. 50? You said 50? Okay. 50 miles per hour. And it seems as though it hasn't given us the distance that's changing, and that's, I think, obvious. So after 3 hours of driving, at what rate is the distance changing? So it's asking us, so it's really, if we're going to label what we're being asked, we're asked dz over dt evaluated at 3 hours. Dz over dt when what is 3 hours, when after 3 hours have elapsed. So I think the main concern is that if I were to come back and plug in, I know I could plug in dy over dt. I know I could plug in dx over dt. Dz over dt is what I'm looking for. And I don't have z. So let's see here. I don't have z, and I don't have, I guess I do have, so let me just go off to the side and make these notes here. I don't have z, right? And I do have x as being 500 miles. And y, as far as y is concerned, I also have y, right? And these, of course, so x, what would x be? Well, x would be after 3 hours had elapsed. X would be, well, it was traveling at a rate of 50 miles per hour for 3 hours. So, or 35 miles per hour for 3 hours. So 35 times 3, right? So 35 times 3. Would you know what that is? 35 times 3?
Yeah, 105.
105? Wow, that was pretty fast. Okay.
I'm going to copy the problem really fast, so that's why I'm going to whiteboard one. Let me just want to make sure.
Sure.
I have all the information.
So x seems to be 105, and y seems to be, well, so 50 miles per hour for 3 hours, 50 times 3, 150. Okay, so it seems like for x I have 105 and for y I have 150. Do we agree with that assessment?
Repeat that again.
So for x,
no.
No? Okay, because
the y, yes, okay. Not the x.
Sure, because so for the x, the idea there was that car A was moving at 35 miles per hour, and it was doing that for 3 hours. So 35 times 3, 105, And that was the reasoning behind that.
Yeah. And also, I think what we need to be careful with is the dx dt. It is 35, but it should be a minus because we're getting closer to what the initial car B spot was. So we're getting closer. If we were getting further away, then it would be positive.
Well, if I don't put that negative there, will it come up in my calculation?
It will affect it, yes.
Well,
You'll get a different answer.
Okay, so let me just go ahead and put that minus then. So it's not going to come up in my algebra. It's not going to automatically change to a minus. Okay.
No, it won't.
So minus 105 would be the conclusion for x.
No, for x, we would go ahead and notice in the diagram, it gives you the total 500 miles that you're there initially apart from each other, car A and car B. But since you traveled 105 miles, you've cut into the 500-mile distance that they were initially away from each other. So now they're only 395 miles away from each other as far as car A, and then car B, the initial spot it was in.
Okay. So I guess what you're trying to say that after 3 hours, it has traveled 500. It has traveled negative 105 miles, but that is just but a portion of the 500 miles that sort of was between car A and car B, and so my real length for between car B and car A is 395.
That's right.
Okay, and I think we agreed that Y was 150. Okay.
That's right.
So it seems like Z is really the only thing that I don't have.
Yeah, and X should not be negative, but it should be a positive 395.
Okay, but I think we said that it would be negative, right? Because
it would be negative as far as the rate dx over dt. That's the one that's negative.
Okay. Wow.
Because you're moving towards the direction of the car B. If we're moving away, then I would keep it positive.
Okay, sure.
Just like the dy dt, we're moving away from where it initially was, and so that's why we have it positive there.
So if both of them were heading north, well, no, if car A was heading east and car B was heading north, would you make them negative?
A would still be negative because it's getting closer to the spot where the car B was initially at.
Okay. Okay, sounds good. So it seems like it seems like we have the Pythagorean theorem, and now we just need to solve for Z. It seems the distance.
That's correct.
So I clearly have X and Y. So I could say that 395 squared plus 150 squared.
That's right.
Is equal to Z squared. And I think we have a calculator in this platform. Do we? Is there a platform on this on tutor.com on like this session?
For a calculator, yeah, you could just put it in there.
No, I was asking that where do you access the calculator exactly?
Oh, you have it on whiteboard 3.
Oh, right. But this is a graphing calculator.
That's fine. You can just type it in.
Okay. So I think it was 395 squared. And so 150 squared as well. So that's 178,525, right? And seems like I want to take the square root of that.
You do.
So I get 442, 422 rather. Okay. So I guess Z is 422.
I would keep the whole thing just to make sure.
The entire thing?
Yeah, maybe 422.522.
Okay.
Maybe you can cut it off there.
Sure. So I guess let me try to factor out 2. Could that be something that would make this a little easier? Or let's see here. Let me just go ahead and try to plug in for what I know. So I have 2, and I know what x is, 395. And I have dx over dt as well, being negative 35. And of course, I have, I'm adding that to 2 times y, which is 150. And multiply that by dy over dt, which I know is 50. And that's equal to 2 multiplied by 422.522. And that is, of course, multiplied by dz over dt, what I want to solve for. So I think that if I divide both sides by 2 multiplied by 422.522, I should be good.
Yeah, so just add everything that's on top, and divide by the 2 times that. Mm-hmm.
Okay. Yeah, I think I trust it. So I think that's good for a solution. I think what I needed to understand was that we would be cutting into those 500 miles. So sort of extrapolating the length of the distance between car A and car B, I think that was at the heart of the question, which made it different than a lot of other types of questions regarding right angles, triangles.
Exactly.
Awesome. Cool.
And each one is a little bit different, so it kind of just depends on what information they give you. If they told you different directions, then that would change it up a little bit too. So it all just depends on the information that you're given at this point.
Okay, awesome. Well, thanks for walking me through it a little bit there.
No, not a problem.
Awesome.
You have a good night.
All right, you too. Bye.